Hi guys, welcome to Amateur Chemistry. So in today's video, I will be turning some household vinegar into glacial acetic acid, which is an extremely useful chemical, and I will use it in a lot of future videos to make all kinds of cool stuff. Before I start making it, let me give you some background on what glacial acetic acid even is, because even though the name suggests it, it has almost nothing to do with glaciers. You see, glacial acetic acid is just nearly an anhydrous acetic acid with a concentration often exceeding 95%, and if you know basic chemistry, you also might recognize acetic acid as the main component of household vinegar. The vinegar from your kitchen often has a concentration of only a few percent. The most concentrated one that I could buy is just 10%, and for cooking and cleaning stuff it is completely fine, because it doesn't really need to be more concentrated, but for some chemical purposes, the water really is a problem. There are a ton of reactions that require nearly anhydrous conditions, some of which are really useful and I have plans to showcase them in my future videos, and that's why I need to make the glacial acetic acid. Anyway, for a chemist, it is pretty intuitive to think that the acetic acid in vinegar can be concentrated to be nearly anhydrous using just distillation, but if this was the case, this video would be like 5 minutes long, so unfortunately, acetic acid is one of these nasty chemicals that just really don't cooperate with chemists, and in order for it to be very concentrated, it has to go through a few chemical transformations. The first one of them has to allow me to somehow turn the acetic acid into a solid that is not volatile and can relatively easily be separated from water. It also has to be capable of being turned back into a liquid. Fortunately, the chemical that I need to make is really easy to synthesize and doesn't require any weird precursors, and that chemical is my good old friend sodium acetate. I really have a lot of nostalgia when it comes to it, because it was the subject of a very old video on my channel, and today I get to work with it again, which is really quite nice. To make it, I just have to combine vinegar with some regular baking soda, and to start, I opened my newly brought vinegar bottle and filled the largest beaker that I got with half of it, which corresponds to about 350 milliliters. I then ran some advanced mathematical calculations on how much baking soda I have to add, and after figuring everything out, I know that I have to use 53 grams of it. I weighed it using my scale, and to start adding it to the vinegar, I turned on strong stirring and proceeded to add the baking soda very slowly. Its addition generates a lot of carbon dioxide, as you can see in the reaction equation, and this in turn makes a ton of foam, which can very easily bubble over and is a pain to clean. For the most part, everything went pretty smoothly, but at one point I of course added a little too much of the baking soda, and the whole thing overflowed, ruining all of my ratios, and what's even worse, flooding my hot plate. I don't have any footage of it, but that popped the fuse and fried the electric motor inside the hot plate, which was really unfortunate, but my dad somehow managed to fix it, for which I am very thankful, and now I could get back to the reaction. I didn't want to repeat the hot plate incident, so I got a big plastic bowl, poured in all of the vinegar, and added the remaining baking soda all at once, which didn't have any bad consequences, and I am now wondering why I didn't do that in the first place. The whole mixture also cooled down a lot, since this reaction is endothermic, and when the bubbling stopped, I poured the whole sodium acetate solution back into the beaker, and now I had to evaporate all of the water. It is going to be an extremely long process, but I can't think of any better one, so I just turned on the heating and waited. I also checked the pH to see if there was an excess of any of the reagents, but it came out to be neutral, so the overflow fortunately didn't affect the ratios that much. The water slowly evaporated from the solution, concentrating the sodium acetate further and further, and at some point the solution turned yellow and cloudy for some reason, which was rather bad, but I pretended like the yellow wasn't there and concentrated the solution further. Anyway, while this is concentrating, let me tell you about a great chemistry supply shop that provides me with many chemicals, BM Chemistry. BM Chemistry sells a lot of difficult to get chemicals of high quality, along with pre-assembled laboratory equipment, glassware and lots of other things, so I recommend you to check out their page, to which I provided a link in the description. Anyway, now back to the sodium acetate solution. At some point a lot of white stuff crashed out of it. It is probably some sodium acetate trihydrate, but when it comes to making glacial acetic acid, the sodium acetate has to be completely anhydrous, and to get rid of all the water, I need to heat it up to a very high temperature. This rips all of the water from the sodium acetate, leaving me with some pretty pure and anhydrous product. When the sodium acetate was dehydrating, I stirred it pretty much the whole time to prevent the formation of a large crystal brick on the bottom of the beaker. I managed to keep most of the sodium acetate as a powder, but some of it still adhered to the beaker, and that made me quite sad. When it looked like no more water was evaporating, I turned off the heating and allowed the beaker to cool down. Its inside looked rather ugly. There were a lot of large chunks of some fluffy and brown sodium acetate and the brick on the bottom that I will have to somehow get out. I decided that it would be a good idea to grind these chunks down to a powder using my mortar, so I got them all inside and managed to scrape the solid layer from the beaker using a metal spatula, and the crystals that formed in it looked really nice. I then ground everything into a coarse powder. The sodium acetate was really fluffy and brittle, so it wasn't too much of a problem. After that was done, I used my scale to weigh the powder, and it turned out that I got a little over 43 grams, which corresponds to a yield of about 84%. It isn't that bad, but it could have easily been much higher if the overflow incident didn't happen. Also, for the next step in making the glacial acetic acid, I wanted to have more than just 43 grams of starting material, so I just processed the rest of the vinegar from the bottle, which meant repeating all of the previous steps. When I was done, I also weighed the powder, and this time the yield was much better, and after all of this preparation, I am now left with around 99 grams of anhydrous sodium acetate. To turn it back into acetic acid, I have to react it with a strong acid. Theoretically, a lot of acids could be used here, but since most of them are a solution in water, which I specifically want to avoid when making the acetic acid, I am left with pretty much a single option, which is 96% sulfuric acid drain cleaner. Since it is composed of only 4% water, the acetic acid produced will still be glacial, and now that I know which acid to use, I ran some more math and calculated that I will need around 36 ml of it, but to ensure that all of the sodium acetate reacts, I went completely overboard and measured out 150 ml. I probably won't use everything, but sulfuric acid is very cheap where I live, so for me, this isn't too much of a waste. Anyway, now I have to set up for the distillation, and to start, I filled a boiling flask with all of the sodium acetate that I made, and assembled a distillation apparatus. I firstly wanted to use a heating mantle, but it is too high for my new fume hood, and makes the dripping funnel impossible to properly position, and in this reaction it is absolutely necessary, and to install it, I just switched to my hot plate, which will hopefully get the job done just as well as the heating mantle. I also greased all of the joints with this random grease that I found to prevent acetic acid vapors from escaping. To start the distillation, I filled up a bowl with cooling water and turned on the water flow to the condenser, filled the dripping funnel with the whole 150 ml of sulfuric acid, and connected it to the apparatus. I then lightly opened the valve, which allowed the sulfuric acid to slowly drip into the sodium acetate in the boiling flask, Immediately upon contact, a lot of white smoke started to form, which was the vapor of pure acetic acid. The sulfuric acid addition generates so much heat that the acetic acid boils on its own and condenses on the walls of the boiling flask. Its vapors also start to escape and flood the apparatus, and honestly, they look really nice and kind of remind me of smoke made by party smoke machines. The reaction that is going on here is just a simple double displacement. Sulfuric acid takes the sodium from the sodium acetate and adds a hydrogen atom onto the leftover acetyl group, creating sodium sulfate and nearly anhydrous acetic acid, which boils from the heat produced by the reaction, since its boiling point is only about 118 degrees Celsius. It then condenses in the water-cooled condenser and collects in the receiving flask while creating a ton of white vapor which escapes into my fume hood through this sketchy latex tube. The whole distillation is rather slow. It has periods where there is almost no acetic acid coming over, and sometimes it just goes nuts and spews out tons of acetic acid, which makes this really nice effect when its vapors touch the cold condenser. The vapor also covers the receiving flask, which makes it really difficult to see what's going on inside. Anyway, I ended up not adding all of the sulfuric acid since the mixture in the boiling flask looked like it didn't need more. It became very black, and with this fog on top, it looked really interesting. Once no more acetic acid was coming over, I stopped the distillation and collected my product. Since it is a volatile acid, I sealed the flask with a glass stopper and some grease to prevent anything from escaping, and now I wanted to take a look at the boiling flask. The black liquid inside had solidified into a solid crystal brick composed mainly of sodium sulfate and unreacted sulfuric acid. It had some really nice crystals inside, but just from the looks of it, I know that this is going to be a pain to clean. Anyway, when I came back to the glacial acetic acid flask, it looked like the acid managed to react with a small amount of the grease, which wasn't a good sign, especially now when I had to weigh it and determine its concentration. It turns out that I managed to make 62 grams, or about 60 milliliters of really nice and clear glacial acetic acid. It has a concentration of about 95% based on the purity of sulfuric acid used to make it. The exact concentration of the acetic acid is quite hard to accurately calculate with my tools. To store it, I poured it into a glass bottle and tightly sealed the lid. Acetic acid is not nearly as angry as, for example, nitric acid, so I did not need to take too many safety precautions to store it for a long time. And now that I finally have it, I can test out some of its properties. I firstly wanted to see how it burns. It is mostly made out of carbon and doesn't have much water in it, so I expected it to burn quite fast, but it turns out that it has trouble even igniting. It barely can sustain a small and dim blue flame, which is quite disappointing, but at least proves that it is not too much of a fire hazard. For the next experiment, I wanted to see what glacial acetic acid would do to a salad, since normal vinegar is often used as a salad dressing, and using it on my salad emulator, which is just a piece of lettuce, it really adds to the taste, but I wanted to see what would happen when I ramp up the concentration 9 times. I expected the glacial acetic acid to at least eat through the lettuce or make it softer, but it seems like it doesn't really dissolve stuff, so in conclusion nothing really happened, maybe except that my whole fume hood now smells very strongly of vinegar, since glacial acetic acid has a really strong smell. Okay, so now I wanted to finally demonstrate the glacial part of this acid, and you probably expected something like it having the ability to freeze stuff, and while that's partially true, because a lot of reactions involving it are endothermic, it actually gets its name from its ability to freeze at a really high temperature of only about 16 degrees Celsius. To demonstrate it, I poured some of my glacial acetic acid into a test tube and lowered it into some ice-cold water. At first it didn't really want to freeze, and I thought that there was too much water around, but when I stirred it with a glass rod which provided a nucleation point, a lot of small crystals appeared. I then let it sit in the cold water for some more time, and when I took it out, everything had solidified into these nice and big crystals that look similar to ice, and they are the reason why this acid is called glacial. As the last experiment, I wanted to see how the glacial acetic acid would clean a coin, since normal vinegar is often used to remove the tarnish and make coins shinier. It works well, but I want more power than that, so I got this old penny that I have for some reason, and as you can see, it is in a pretty bad state, and to clean it up, I dripped some of the glacial acetic acid onto it. It reacts with any oils and contaminants on the surface of the coin, dissolving them and leaving me with just pure copper. It really packs a lot of punch, because just after a few minutes, the coin was really shiny. It also seemed that the acid dissolved a little bit of the copper, but at least I now have a really clean penny. Anyway guys, to those who made it that far, thank you very much for watching, like and subscribe if you enjoyed the video. Also, big thanks go to my Patreons, especially Isaac Von Liu, Lorenzo and Dangerous Lab, as well as R2D2, Riley Reprobul, Joseph Cudi and MI for supporting my channel. If you would also want to support my work and gain access to exclusive content, you can consider becoming a Patreon, and see you guys in the next video.